Vehicle Danger Sensor. Vehicle Danger Sensor. The Project Vehicle's Danger Sensor is a detachable device that can be mounted on both front and rear side of vehicle to measure distance from obstacles. It uses LCD to display distance readings placed in a visible and easily noticeable location and an alarm to alert drivers when danger is detected.
This vehicle danger sensor helps prevent collision by alerting drivers when objects are too close. It uses ultrasonic sensor to measure distance and LCD screen to display it. A buzzer sounds when obstacles are near and stop once clear. The sensor acts like an extra eye, especially for the blind spots. It is built with the common parts such as Trivino buzzer, LCD, wires, and the ultrasonic sensor, enhancing safety in tight parking spaces.
These are the materials that we will be using in creating our project.
The Arduino Uno, or the microcontroller or the brain of the system, it processes the data from the ultrasonic sensors and calculates the distance and controls both the LCD screen and the buzzer based on the programmed danger threshold. The next material is ultrasonic sensor, the primary distance measurement component. It emits high-frequency sound waves and measures the time it takes for the echo to return after bouncing off an obstacle. The two sensors allow for monitoring both the front and the rear of the vehicle. The next is the LCD I2C module, the visual output component. It displays the calculated distance reading in real time, allowing the driver to see exactly how far away the obstacle is. The I2C interface simplifies the wiring to the Arduino. Next is buzzer, the audible output component. It acts as the alarm system, automatically activating with an audible tone to warn the driver when the distance falls below the preset safe limit or the danger zone. Next is breadboard, a prototyping base used to temporarily and conveniently connect the electronic components like sensors, buzzer, LCD to the Arduino without needing to solder. And the last material is the wires, hook up female and normal. The electrical connections used to transmit power, ground, and data signals between all the components, ensuring the entire circuit is operational.
This is the flowchart of process and vehicle danger sensor. The system starts and checks for obstacles. If no obstacle is found, the LCD stays blank. If an obstacle is detected, the system measures the distance, display it on the LCD, and check if there is any danger. If danger is detected, it activates an alarm. Otherwise, the alarm stays silent and the process repeats.
These are the numbered process of our project. Number 1, the ultrasonic sensor mounted at the front or rear of the vehicle continuously emits sound waves to detect nearby obstacles. When these events hit an object, they bounce back to the sensor, allowing the system to sense the presence of obstacles around vehicle. Number 2, the sensor measures the distance by calculating the time difference between sending and receiving sound waves. Using the speed of sound, it accurately determines how far the object is from the vehicle, giving the precise distance readings in centimeters. Number 3, the Arduino processes the measured data and displays the results on the LCD screen. The driver can easily read the distance value for both front and rear sensors, and if an object is too close, a warning appears on the screen to alert the driver. Number 4,
The system constantly monitors the distance between the vehicle and any nearby obstacles. The system has a predefined threshold for what constitutes a safe or acceptable distance. As long as the detected obstacle is beyond this threshold, the system remains inactive. This inactivity prevents unnecessary alerts, which would be distracting and annoying for the driver when there is no risk of collision. The system is designed to be helpful, not bothersome, in routine driving or maneuvers.
Number 5.
If the obstacle comes too close to the vehicle, the control unit interprets this as potential danger. The system instantly triggers an audible warning to alert the driver, giving them immediate feedback and time to stop or correct their maneuver before contact is made. The frequency of the beeping often increases as the distance decreases, intensifying the warning.
And last, number 6.
The alarm is designed to remain active until the danger is resolved, ensuring the driver takes corrective action. The driver must adjust the vehicle's position or stop moving closer to the obstacles. The buzzer will automatically silence only when the distance sensor detects that the vehicle has returned to and is maintaining a distance greater than the activation threshold. Simply muting or disabling the buzzer manually is usually not an option because the system is designed to enforce safety until the physical danger is removed.
The vehicle danger sensor is significant because it enhances road safety by detecting nearby obstacles and alerting the driver through visual and sound warnings. This system helps prevent collision, especially when parking or reversing, and reduce accident by human errors. It also demonstrates how sensor and microcontrollers can be combined to create an affordable safety device that can be installed in any vehicle. Overall, the project promotes driver awareness, protects lives and property, and supports the development of innovative vehicle safety technology.
So now, let me show you the process of wirings. First, we will be needing Arduino Uno, one breadboard, 2 ultrasonic sensor, 1 LCD, and 1 buzzer. Next, we will connect the negative leg of buzzer into GND and positive leg into 5V. For front ultrasonic, connect the trig pin into pin 9 and echo pin for pin 8. Then, connect the VCC in 5V, then GND to GND. For rear ultrasonic, connect the trig pin into pin 6 and echo pin in pin 5. Then, same as front ultrasonic, connect the VCC into 5V, then GND to GND. For LCD, connect the STA in A4 and connect SCL into A5. Again, GND to GND and VCC in 5V. Then, connect the positive in breadboard into 5V, then negative into GND. Copy the code, then paste it before simulation. Check the code for the address of LCD and change the type of LCD. If the distance measurement reaches 35 cm, it will trigger the buzzer and display warn. When the object reaches 36 cm above, the buzzer will stop and display safe. Let me show you the code for this wiring. Using this code, you can easily identify the wirings for each component. This code also helps to program and to give instruction to the hardware. Code breakdown. Number 1. Library and component setup. It imports the LCD libraries and initialize the 12x2 I2C display. This allows the Arduino to communicate with the LCD and show distance reading and alerts. Number 2, pin configuration and setup. This defines the pins for ultrasonic sensors and the buzzer. In setup with open and closed parentheses, these pins are set as inputs or outputs. The LCD is start and serial monitor communication begins. Number 3, distance measurement function. This sends an ultrasonic pulse and measures how long it takes to return. Converts the time into distance in centimeter using the speed of sound formula. Number 4, main loop, display plus warning system. It continually reads distance from both sensors, shows them on the LCD, and turns on the buzzer if any object is detected within 35 centimeter. Lastly, let me present the circuit diagram. These are the references that we use in creating our project. That's all. Thank you, and we hope you learned something and enjoyed watching our video presentation.